Okay, so hello everyone. Welcome back from our summer break. To get us started this term, we have the pleasure to welcome our colloquium speaker, Professor Richard Dawid. Richard is a professor of philosophy of science at Stockholm University. He actually started off as a physicist at the Technical University in Munich and then at the Lawrence Berkeley Laboratory before switching to philosophy. And in an era where many of our high energy theories lack direct empirical evidence and also rely on some counterintuitive metaphysical commitments, such as the multiverse or extra dimensions, Richard's work focused on the philosophical aspects of some of these theories, where he considers a meta-empirical assessment of them, something that he will tell us about in the context of inflationary cosmology. So please, Richard, the stage is yours.
Thank you very much. Thank you very much for the invitation. Very glad to be here. What I want to talk about today is a specific context in which I think the concept of meta-empirical assessment, which I'm interested in, can be applied. I did this work with Casey McCoy, who is now at Yonsei. To give you a broader context of this talk, even though Guy has basically done that already, in physics, physicists face a situation where often theories are not easily empirically confirmable and remain in a kind of limbo. Some observations in favor of the theory, unclear situation, often incomplete theory development for a very long period of time. And in those contexts, it is important to nevertheless have some grasp, some assessment of the theory's prospects or the probability that the theory is viable. And in recent years, it happened more frequently that physicists themselves engaged in discussions of that kind, and engaged in those discussions in a way that contained implicit or sometimes even explicit elements of philosophical reasoning, actually. What I want to argue is that in order to make such debates, such meta-level debates productive, it is important to give them a clear epistemic basis. And that basis, I feel, is sometimes missing or not sufficiently well developed. And what I want to discuss today is one example of this. So the broad project in which this is embedded is the idea to look into such debates, into physics debates that partly play out at the meta level, and reframe them by spelling out its epistemic basis and try to understand those debates a little better that way. And there are one current work in progress is with Siska, whom some of you I know, who is here in Stockholm, on the Mondian philosophical reasoning in support of their theory that is explicitly philosophical and referring to philosophical concepts, actually. This talk is another investigation along those lines. With Casey, we look into the debate on the status of inflation that was particularly conspicuous a few years ago in connection with the Steinhardt papers. And a crucial concept that will play an important role, even though it will get to the stage only at a fairly late point in my talk, is the concept of meta-empirical theory assessment. So a core claim of mine is that epistemic commitment strongly relies or has to rely, if it can be effective, on assessments of the spectrum of unconceived alternatives. And strategies to assess that spectrum in an effective way are strategies of meta-empirical theory assessment, and I will say a little bit about that later, and I will use meta-empirical assessment in order to get a better grasp of that debate in the end. So the situation of cosmic inflation, of course, today is that it is a standard position in cosmology. And it is a standard position including and involving concepts such as eternal inflation and the multiverse as core ingredients. A majority of cosmologists arguably assumes that or claims that inflation is at this point well supported by data, even though there is no actual, let's say, conclusive confirmation of the hypothesis. Now, in a series of articles starting in 2014 in scientific journals and then reaching towards an exchange in Scientific American in 2017, Ils, Loeb, and Steinhardt argue that, on the contrary, inflation is in very serious trouble. They claim that what they call the classic paradigm of inflation, the original paradigm of inflation, is next to ruled out by the data, while the more recent understanding of inflation does not amount to a scientifically testable theory. And now these claims have been quite forcefully rejected by exponents of inflation, first reacting to their initial article and then again 40 or close to 40 inflationists in a response in Scientific American to the Ils, Loeb, Steinhardt article there. Now, of course, this exchange, in particular the exchange in Scientific American, was perceived as a highly polemical exchange. We would argue, however, that it is an exchange that is philosophically interesting, that it has substance, and it is interesting to look at it, let's say, from a philosophical perspective. So that will be our goal here, to understand what the core of this dispute seems to be if one tries to apply a more philosophical perspective. So let's first say a little bit about the ILS argument. And one may distinguish two levels of their argument, even though in the end we will see that they play out in fairly similar ways, and the answers or the responses also play out to those claims also play out in fairly similar ways. So the starting point of ILS is that they look at the very simplest models of inflation, of single field slow roll inflation, and claim that those models have fine-tuning problems. So they are close to being ruled out in their understanding. Then, in particular, given the response of Guth et al. To their initial paper, they concede that there is a wider class of generic models of inflation that agrees with the data we have, but they point out and they emphasize that models could also be built that match very different experimental data sets than what we see, if that is needed. And they infer from that, or they take that as a case for claiming that what is generic depends on the empirical constraints we have, and of course will also depend on new conceptual input one may get in inflation. So it is not clear that what is considered generic now will be considered generic later on. And from this, and the high flexibility of model building in this wider framework, they infer that the theory of inflation actually does not predict data. Therefore, even though one can test model-specific spelled out models of inflation, testing those models does not amount to, well, they wouldn't call it confirmation of the theory. It doesn't amount to testing the theory, I should say. So the theory of inflation, in their understanding, is not empirically testable. Now, so far, this was, let's say, within the canonical contexts of scientific inference. Inflation includes today the additional aspect of the multiverse. And in the multiverse scenario, of course, one has all, let's say, possible solutions to the dynamics playing out somewhere in the multiverse. And in order, therefore, to understand how probable a given outcome is, one needs a measure over the set of universes. Now, it is clear that the most intuitive suggestion of such a measure has conceptual problem that has to be addressed, the youngness problem, without going into any detail. But it is not clear which, the physics does not enforce any specific measure. So one can choose measures according to what seems to be on an empirically basis plausible. Now, ILS claim that this destroys empirical testing as a method of falsification, because if the measure can be chosen in order to make the data fit the theory, then the data doesn't seriously test the theory anymore. Things are kind of upside down. Therefore, once again, they say that inflation has left the context of genuine scientific reasoning, where a theory needs to be critically tested. So they call this modern framework of inflation postmodern inflation. So their conclusion is that there used to be a phase in inflation, called, I mean, in the development of the theory of inflation, called classic inflation, which of course is the phase where Steinhardt himself played an important role, and that was scientific. Because one only considered the simplest models, and the theory was sufficiently constrained to be predictive, and the theory avoided the multiverse. But this approach has serious problems. It requires fine-tuning, and it's not clear whether the multiverse can be avoided at all. So one needs to, there's pressure to go towards postmodern inflation, but this postmodern inflation in the understanding of ILS is too flexible. It allows arbitrarily complex models, assumes the multiverse, and therefore is not a predictive theory. It's not falsifiable, therefore not scientific. Now, the Good et al. Response is, in effect, the core of the response is that the testability of models already makes the process scientific. If you can develop models on the basis of the theory, and you can test those models, that's sufficient for having a scientific process. And accommodation, they claim, an eliminative reasoning that plays out in the context of testing those models are standard elements of science. So the defenders of inflation would say that in inflation, things play out in a very similar way than in other fields of science. Maybe things are more complicated. It takes longer to reach conclusive understanding. But in principle, what happens is not that different from previous contexts in theoretical physics. Moreover, they point out that the generic class of models was confirmed, so it is more than accommodation that is going on if one looks at features of the observed universe, such as near Gaussianity or isotropy that are represented by generic classes of models. And with respect to the multiverse and the measure problem, they claim that it is legitimate to expect or to wait for theory to generate a better understanding of the correct measure. That's, in their understanding, once again, part of the scientific process at a stage where the theory is not, the theoretical context, let's say, is not fully understood yet. So they also have some more specific criticism about the fine-tuning issue, but that's not important for us at this point. Now, if we look at this debate from a meta-level perspective, let's say a philosophical conceptual perspective, one can identify a specific philosophical take ILS has on scientific reasoning. What is noticeable is that they don't talk about confirmation. They don't talk about, in Bayesian terms, increase of the probability of the hypothesis given the evidence. They talk about, they have a kind of a likelihoodist perspective, which, of course, in the context of testing a theory is nothing unusual whatsoever, right? So they say, and I give this quote here, what they do say about requirements for accepting a theory is that the question is whether measurements agree with what is expected, the given paradigm. And more specifically, they say that one needs both the question whether the observation is what is expected given the specific potential, and B, is that potential what is expected according to what they call the internal logic of the paradigm. Those have both to be answered in the positive, in the affirmative, in order to have a basis for endorsing the theory. So so that's what they give, and they deliberately do not talk about confirmation, right? So they keep it within that framework. So they adopt what one can call an extended likelihood view that relates acceptance of a theory based on the evidence to likelihoods, probability of evidence given the theory, rather than going all the way to spelling out or discussing probability of the theory given the evidence. And that later on that will be important. Moreover, however, and that's also important, they include the probability, the expectedness of models given the theory, given the paradigm. So they have something like this below here: theory is to be endorsed if the sum over the models we have, the sum of evidence given the models times the probability of the model given the evidence. So what they call expectedness of a specific choice. This needs to be above a certain threshold in order to endorse the theory. Now, Guth et al., to the contrary, endorse what one may call a straightforward empiricist view, where they say that the testability of models suffices. So they don't require that extra step of understanding full scale the spectrum of models, let's say. I mean, of course, the genericity of model to a certain extent does go beyond that. But in their defense against ILS, they do not emphasize that mostly, but they emphasize this testability of models as the core of scientificality. And moreover, they say, and of course this is related, that this can eliminate reasoning, accommodation, developing models that fit the data can be helpful for further conceptual evolution, even if the understanding of the theories and predictive import may be in flow at this point. One example being this measure in the multiverse case. So if one compares those two positions, the way they are explicitly spelled out, one would say that ILS present a traditional view on theoretical testing, where scientific theory already needs to establish stable prediction before empirical testing can start. So one needs to first come up with a complete theory, then one needs to test that theory, and then one needs to confirm or reject. While if one would want to characterize the Guth et al. Understanding of the process at the theory level, that would be much more in flow. So the theory doesn't need to be fully spelled out. The impact of the evidence may not even be fully understood. It may be driven by further theoretical development. What we take this evidence to, in which way we take the evidence to impact the theory, or to be at variance or in agreement with the theory. All this may change, as long as at the model level there can be clear-cut empirical testing. And it seems that this more processual view of the scientific revolution first reflects the current situation in fundamental physics, not just in inflation, but in string theory and in other contexts of quantum gravity. And it is also, as we have pointed out, it is fully consistent with an empiricist understanding, as long as models that highlight specific predictions and that can be tested in that regard can be formulated. Now, if one looks at the situation along those lines, it seems that ILS just have an old-fashioned, overly rigid view of theory testing. They clearly do point at some deficiencies and insufficiently understood aspects of the current view on inflation, but they don't seem to have a fundamental point. They don't seem to have a point that is as substantial as they take it to be. Now, the suggestion is, and this suggestion, of course, is in line with what I said in the very beginning, the suggestion is to have a slightly different perspective on this. And the point would be that in those contexts where assessment of a theory, of a theory's viability is at stake, just looking at it from a likelihood is to a frequentist perspective, without fully spelling out a Bayesian account, an account that leads all the way towards stating a probability of the hypothesis given the evidence, just is not enough. It is not enough for representing what is actually at stake and for representing the potential significance of arguments. So the point would be that ILS would be able to make a more precise and the more interesting claim if they try to couch it in a Bayesian framework, so to say. So one might try to think what that would look like if they did it, and then discuss their charges on that basis. So that's what I now want to do. I want to discuss probability of the theory given evidence rather than just probability of evidence given theory. And the claim is that the story becomes more interesting that way. So the starting point, and one point that would suggest that actually, even though ILS start within a kind of, one may say, Popperian framework that does not focus on confirmation, likelihoodist framework, as I called it, in the background of their thinking, there may be, after all, more than that. There may be probabilities of theories. And one can see that if one asks the questions, why aren't they actually satisfied with testing models? Why do they, unlike Guth et al., why don't they agree that actually testing models and rejecting models is already a scientific process? So that's perfectly fine. So if they did that, their criticism, one might claim, would deflate to a criticism of terminology. So they might just end up saying, well, don't call inflation, the theory of inflation, a theory, because we only want to call a theory what can be tested. At this point, let's just call it a framework or whatever. So that would be a terminology issue. It would not be awfully interesting, and it wouldn't have the bite they want to give their charge. So, but there is a natural answer, a natural response to why they are not satisfied with testing models, and that plays out in terms of probabilities. And that response would be that there are so many possible models that inflationists lack the prospect of endorsing a specific model based on the data. So it's just not satisfactory to test models because we don't believe them anyway, so to say, the individual models. And in that context, they may think, if that's the context, the only justification for testing models would be to generate credence for the theory, for the next level of theorizing. One might also argue that the Guth et al. Justification of eliminative reasoning in their response to ILS implicitly relies on probabilities, because accommodation in the eliminative reasoning plays out, of course, within the framework of inflation. So one might argue, if there is no reason to believe in inflation, there would also be little reason to focus on eliminative reasoning within that framework. So why should we then do that rather than do something completely different? Why is it interesting if we cannot confirm substantially specific models, and we cannot we don't have any trust in the framework either? So a certain level of trust in the framework or in the theory of inflation seems to be a precondition for for acknowledging that argument as a powerful argument. So implicitly, it seems that the debate does address credence in inflation anyway, which of course then would give an additional reason to look at it from that perspective. So if one frames ILS in terms, in Bayesian terms, let's say, then their argument would be the following. They would say, testing an inflationary model does not generate significant credence in that model because there are just too many models, also too many models that can agree with that data. It does not generate credence in the theory either because model building is too flexible for extracting genuine predictions from the theory. Therefore, the research context does not significantly change credences anywhere, either at the level of models or at the level of theory. And this, from a Bayesian perspective, one might argue, renders the process scientifically questionable. It's not clear what is actually gained by doing those investigations. Now, if Guth et al. Would need to respond to that credence-based version of ILS, they could not just point at the statement, well, but formally it's fine just to test models, because that would be exactly what this Bayesian ILS form argument would question. It would say, well, but if you test models, you need to explain to us first why you trust the framework within those models play out, at least to a certain degree. So such a response would need to be based on pointing at actual trust in inflation. And now, two claims would be that that's, of course, what inflationists, cosmologists believe anyway. They do have trust in their theory. And second, the more philosophical point would be that, and I will try to argue that given the empirical stages of inflation, that trust must be based in part on meta-empirical theory assessment. So one needs to go a little beyond the canonical understanding of Bayesian theory assessment to understand what's going on. So what I want to point out at this point is that there are two levels of these suggestions, right? One is just look at it from a Bayesian perspective that has been done in the recent slides. So this is just a methodological suggestion, let's say. And the second one is, given that you have this Bayesian perspective, the idea would be that in order to understand what's going on, to understand credence in inflation on the side of inflationary cosmologists, you need to acknowledge a specific type of reasoning, which is meta-empirical theory assessment. So this is a second step that goes beyond just using the Bayesian framework for analyzing the situation. Now, if we want to say a few more words about the trust inflationists do have in inflation, as it's clear, of course, that inflation is considered an element of standard cosmology. So there should be an epistemic aspect to this, and it's also a widespread view that there are substantial reasons for having trust in its viability. And I just want to show one quote by someone who, of course, is a particularly outspoken supporter of inflation. I won't read the entire quote, but just the last sentence. So in effect, he says that it started out as a speculation, but now basic principles of inflationary cosmology are rather well established. So that's in 2007 already, he says it. Now the question is, how can one understand this credence in the theory if, as we have seen, or as one may plausibly claim, it is difficult to reduce that trust to empirical support. So this flexibility of model building, of course, impedes the straightforward empirical data-based reasoning in favor of the theory of inflation. And so at this stage, let's assume, of course, that's also debatable, but let's assume that ILS do have a point here. It is indeed very difficult to understand the significance of the pure data as and the confirmation value of pure data for the overall theory of inflation. And now I want to present a framework which I claim is helpful in contexts like this, and this is meta-empirical theory confirmation. So the idea here is that theory confirmation comes in two kinds. It comes as empirical theory confirmation, where there is increased credence for a theory's viability based on the empirical data that is predicted by the theory, empirical data in the theory's intended domain, that is. And there is non-empirical theory confirmation that increases credence on a theory's viability based on other types of evidence. And now, of course, these other types of evidence can be of various kinds. And I argue, however, that there is one particularly effective form of non-empirical confirmation, which I call meta-empirical theory confirmation, where the increased credence in a theory's viability is based on observations which are beyond the theory's intended domain, but those are observations that allow inferences on the spectrum of unconceived alternatives. So they allow inferences with regard to the question, how many other possibilities are there to develop a theory about that subject matter, a theory that can account for a given data set, let's say. Now, meta-empirical reasoning also works in the presence of empirical data. And I would claim that it plays an essential role in all kinds of empirical confirmation. And if it comes in conjunction with or it accompanies empirical data and empirical confirmation, then I want to call it meta-empirical assessment rather than confirmation, because it's not confirmation in the absence of empirical data within the intended domain of the theory. So if one compares in this strict case of non-empirical confirmation, where there is no empirical data in the theory's intended domain, the prime example of this context, which is the example where I first discussed it, is string theory, where you don't have empirical confirmation of the theory. And if one compares this type of meta-empirical confirmation one may have to empirical confirmation, what is important to point out is that the mechanism that plays out at the ground level in the case of empirical confirmation plays out at the meta level structurally in the case of meta-empirical confirmation. So what you have are meta level observations F, and we will come to what those observations can be, that actually are predicted by a meta-level hypothesis on limitations to underdetermination. So the hypothesis is there are only few, or maybe just one theory that can be built on that subject matter based on certain scientificality conditions and given what we know about the context. Now, this hypothesis would predict kinds of meta-level observations, and if I now make those observations will, in the same way this happens in empirical information, they will increase the probability of the meta-level hypothesis. And now, if the truth of the meta-level hypothesis is positively correlated with the truth of, or the viability of theory, then this data F increases the probability of the theory. So what we have then in the Bayesian terms, where any increase of a theory's probability is confirmation, not conclusive confirmation, but is some confirmation, then what we find here is that these meta-level observations actually confirm the theory. So we have meta-empirical confirmation. That's the basic idea. And now the question is, what kinds of meta-level observations could there be that can play that role? One crucial observation, in a way, the core observation would be an alternatives observation. So I list here three types of meta-level observations. I call them arguments here, but all those arguments, each argument is based on a specific type of observation. So in the first case, the non-alternatives argument, the observation is that despite extensive search, scientists haven't found an alternative theory. Or that's what the physicists who use that argument claim. The meta-inductive argument would be based on the observation that other comparable theories in the research field, in some way comparable, most effectively they would be comparable in sharing other meta-empirical arguments. So, for example, other theories that had an alternatives argument in their favor, let's say, were empirically successful later on once they were tested. That would be a meta-inductive argument. And then there would be the unexpected explanation argument that is based on the observation that the theory explains something without having been developed to that end. Now, this may be at a conceptual level. It may not amount to actual empirical predictions, but just explaining a conceptual feature of another theory that had not been understood so far. That could also play out in the absence of empirical confirmation. If there is empirical confirmation, then unexpected empirical confirmation, often in the philosophy of science, often called novel confirmation, which is confirmation by empirical data that hasn't entered the process of theory development of that specific theory, that would also be an example of unexpected explanation. So those are the three arguments. And the point would be that each of those arguments on their own would be fairly weak, because you would have arguments that attack it directly, but in conjunction, they can be fairly strong. So if you have two or even three of those arguments, and all are very significant, these can generate meta-empirical confirmation in the absence of empirical confirmation. And even more so, can it play the role of an important element of meta-empirical assessment in the context of the empirical confirmation process. Now, if we now think about ways of using this in the context of this debate on the epistemic status of inflation, it is striking that the no-alternatives argument plays exactly the role that one needs in order to avoid the problem or dissolve the problem one faces in the context of empirical confirmation. So the problem of empirical confirmation was that testing only reached up to the level of specific models, but they could not generate substantial credence for any of those models. Now, in the case of the no alternatives argument, and actually in the case of all three of those meta-empirical assessment arguments, the mechanism plays out at the theory level. So clearly, obviously, there is no alternatives argument with respect to models, it's just the opposite. But there can be no alternatives argument in favor of inflation. So if such an alternatives argument works, and if it is, let's say, sufficiently supported by meta-inductive argument or maybe also by unexpected explanation arguments, then what would happen is that this no alternatives argument is supported by the confirmation of models, even in the absence of significant prediction at the theory level. Because what is now the crucial point is not that the theory specifically predicts this data, but rather that this data does not seem to be adequately represented by any other theory. And the more one narrows down the options by being more precise about data, the stronger the no alternatives argument becomes. So the more specific the data is, the more difficult it would seem that alternatives can be built to the theory in place, even though the theory itself is so flexible that it's difficult to call it a rigorous confirmation, a rigorous prediction of the theory. So this means that the mere fact that there is a model that agrees with the empirical evidence suffices for generating meta-empirical confirmation for the hypothesis. And the more stringent the data, the stronger that confirmation, the higher that confirmation value become. So this can step by step strengthen the no alternatives argument. And on that basis, new evidence can therefore significantly increase the trust in the theory. So what I want to emphasize here is that this is not a judgment on the case of inflation. So surely I don't have the role here to intervene in that judgment. It is just a presentation of a line of reasoning that can be applied to the extent this no alternatives argument works. So if of course there are participants to that debate who deny the no alternatives argument, who say that's just not right for a number of reasons, either because inflation is questionable itself, or because there are other approaches that should counter serious alternatives. I don't want to intervene in that, right? That's not what I want to do. What I want to do is, given to the extent an alternatives argument can be built, how would it work out? What role could it play? And the claim is it could play a role of meta-empirical confirmation. So it could generate trust in the hypothesis, even in this epistemically difficult situation of empirical data that one faces in this context.
Sorry,
so
Richard, you have more or less 5 minutes left.
Okay. Yeah, I'm nearly done actually. So having said that I don't want to intervene in that debate. Of course, I can give you a quote by Andre Linde once again, who does make this point, right? Who makes an alternatives claim here when he says that inflationary scenario is very versatile. After 25 years of persistent attempts of many physicists to propose an alternative, we still do not know any other way to construct a consistent cosmological theory. So that's a clear-cut an alternatives argument. To what extent he is right is another question, but it's clear that this kind of argument is presented in that context. Now, just very briefly, because we have basically run out of time, looking at the other arguments, there are contexts, also reasons to claim that meta-empirical assessment, a meta-empirical argument, and unexpected explanation also play a role in assessing the theory of inflation. So clearly, of course, meta-empirical arguments are also fairly flexible, right? You can extend the regime within which you want to look for them basically as much as you want, as long as you have a significant success story to tell. So mostly what a meta-empirical argument would be looking for is other cases where there is an alternatives argument, and one can look for them in the broad context. So one could look them from, if one looks at the situation from a high energy physics, particle physics perspective, one can look at the standard model success stories, or from a cosmological perspective, one could look at the viability of GR of many orders of magnitude, as for example, it has been in his recent book stressed by Tim Peebles. So there are those cases of meta-empirical arguments in favor of the theory that can be used in favor of the theory. And I just want to cite one interesting, though also somewhat controversial example for an unexpected explanation argument, and that would be entropic reasoning. If one takes entropic reasoning to be a viable solution to the cosmological constant problem, that would be a paradigm case of unexpected explanation, because inflation was developed for an entirely different reason, completely unrelated to entropic issues. And then, if that works out, and if one thinks it works out, one thinks that this in the end provides the basis for an entropic explanation of a core problem in physics, a very different kind of problem. So that would be unexpected explanation. Now, to conclude, I think it's fair to say that inflation is not postmodern. However, so postmodern as this meant in this pejorative term, that it is decoupled from empirical evidence. But assessing its epistemic status arguably must rely on elements of reasoning that go beyond the canonical view of the scientific process. So in some sense, I would suggest that one can interpret the difference of opinion between ILS and Guth et al. In terms of their implicit endorsement of meta-empirical assessment. So they don't explicitly, neither faction explicitly endorses it or introduces it into the debate, but my claim would be that it is implicitly endorsed by the defenders of inflation, while it is rejected by ILS, who try to defend a more rigid understanding of what scientific testing amounts to. And I would think that they are right in pointing out that if you have this rigid understanding, the status of inflation looks difficult. So this rigid understanding may not be sufficient for understanding trust in inflation that is shared by many exponents of inflation. Yes, that was all I wanted to say. Thank you.
Okay, thank you very much. It was a very lucid talk. We have a few questions now. So people who have questions, please raise your hands.
Okay.
Before we start with the questions, let me just read out some comments that Irania made because she had to leave. And if we'd appreciate your reactions, because then she can have a look later. Mm-hmm. So she wrote, first, I would not say that it is correct that most cosmologists accept eternal inflation and the multiverse as an ingredient of inflation. She personally agrees that inflation implies eternal inflation, but many observational cosmologists are content to test inflation's mechanism for generating cosmic structure and wait for some better theory to explain away eternal inflation. So maybe that was the first reaction. And the second one, she said that she doesn't think that we ever test anything other than models. Einstein's GR also implies many cosmological models, and we test them one by one. The standard model of particle physics is also just one model from an immeasurable number allowed by quantum field theory. Therefore, the ILS argument makes no sense. So maybe you could react to any of those points, we'd appreciate.
Yes, well, the first point, I mean, I would say for sure it's an absolutely fair point with respect to open-mindedness. So one would say, of course, it is the way current inflation can currently be understood on a coherent basis. It may be that something better comes around, and at that stage, I would think it's an absolutely fair point to say that one should not rush towards endorsing this as the only possible option. Still, I would think that if one at this stage spells out inflation as a coherent hypothesis to the extent that is possible, most or many cosmologists would argue that requires the element of eternal inflation. With respect to the second point, I think I absolutely agree. I think this is, in effect, this is saying in stronger terms what I wanted to say at the end of the first part. If you look at this from an empiricist or a likelihoodist perspective, it just makes no sense to say that testing models is not enough. However, if one looks at it from a Bayesian perspective, from a probabilistic perspective that takes it to be the aim of science to generate credence in a theory, then it's a different story. Then of course it's still true that we test models, but these model testing are uncontroversial, let's say. I mean, the significance of that model testing is uncontroversial as long as they can be put into a context of amounting to a theory's predictions. So if the theory already constrains what can happen to a significant degree, and then we need specific models in order to compare whether any model actually is fully in agreement with the data, then we can say we have both parts. So we test the model, but testing the model also generates credence in the theory. While in the context of inflation, due to this abundance of models, that step is problematic. So there needs to be, if one thinks that generating credence in a theory is part of the scientific goal, then one needs other strategies in order to have that credence. It cannot just rely on model testing. That would be the idea.
Okay, thanks for that. We have, I guess, Alex now with a question. Please unmute yourself and ask away.
Yes, thanks for a very interesting talk. I wanted to ask about meta-inductive arguments. Is like saying that, oh, something like this already exists. Is that like a meta-inductive argument? Saying, for instance, in the case of inflation, saying, okay, we know we have a good reason to believe that scalar fields exist because we found the Higgs and that's the scalar. We have also good reason to believe that cosmological constant equations of state are something that can happen because we see that today. Is that part of the meta-inductive argument?
That would not be part of the meta-inductive argument, because that would just amount to, so to say, winnowing down theory space, let's say. So we either winning down theory space or establishing preconditions for what we assume with respect to the given theory, but it would not amount to an assessment of unconceived alternatives. And the crucial point about meta-empirical assessment is that it's a strategy focused on assessing unconceived alternatives. So you need some meta-level observation that addresses that issue, not the issue how well a theory agrees with the data, which is about this theory, but the question how, for example, how easily we can predict. So maybe the most straightforward way of understanding meta-empirical reasoning would be to talk about extreme cases. If we lived in a scientific world where any consistent scientific theory we develop is predictively completely successful, So whenever we develop a theory and we test it, we find, yes, it's exactly like that. At some stage, we would infer from that actually there is only one solution, because otherwise, why should we always pick the right one, right? We don't have a truth detector, so we develop the theory we happen to find, and if that's always the theory that works, and it works perfectly, at some stage we would infer, well, the world is of a kind where there is just one way to develop a scientific theory. So it's just about finding the consistent theory, and that's it. On the other hand, if we lived in a world where this never works, where scientists try to develop theories, they account for the data they find, and at the next turn, now they test the theory, they look at they collect data in a slightly different context, and they always find this is wrong, it never works. Then they would infer at some stage, okay, obviously this is hopeless. Obviously there are so many theories that can be built that it's just hopeless you cannot predict on that basis. There is underdetermination to an extent that makes prediction hopeless. And of course, there is no example of the first kind, but there are examples of the second kind, or that come close to the second kind. So some contexts in economy, for example, are quite close to that, right? You can always accommodate what happened, but you can never predict what's going to happen, because there are too many ways of representing the situation. And so that's the question meta-empirical assessment addresses. And that's the mechanism it uses in order to understand whether we can have trust in a theory or we can't. So it's entirely focusing on this meta level. It's not looking, I mean, it uses, of course, agreement between theory and data, but that's not the characteristic aspect. It's not what makes it meta-empirical assessment.
Fawad, please.
Hi, Richard. It was a very interesting talk. Thank you.
Thank you.
So I will have a comment and then a question. The comment is, I think, in line with what you said, basically, but probably reformulating it a bit. So when one is making comparisons between inflation and the standard model and gravity, I think the comparison is not completely fair, because standard model and gravity are highly restricted by consistency conditions. For gravity, we have essentially no freedom, entirely coming from consistency, absence of instabilities, etc. And the same for the standard model. Once you supply some part of the particle content, then the gauge principle and consistency completely determine the rest of the theory. So these are very, very highly restrictive, highly predictable theories. You cannot just go and tune a part of it and say, okay, now I get the new result. The whole theory goes wrong, basically, which is not the case for inflation. And this, of course, points out the basic issue that for inflation, we don't have a fundamental principle, which we have for gravity and for the standard model. For inflation, there is no fundamental principle. We just put up something, we have GR, and we just put in a kind of extra ingredient there and try to cook up something to get correct predictions, and it works out. So inflation is a very good phenomenological model, but there is no first principle understanding of it. So this, in some sense, I think is maybe the crucial issue, that there is no first principle understanding of what is happening in inflation. So in that sense, it's very different from GR and the standard model. So my question then is that essentially that, so you, of course, you summarized very nicely the arguments of these two different groups. There's another kind of argument which I have kind of come across as criticism of inflation. And I'm wondering if this has figured out in this philosophical discussions and all that. The argument essentially is that inflation stretches known physics to a domain which is beyond its area of applicability. Essentially that if we believe in inflation, then our whole universe essentially starts at a at a stage when the whole universe is smaller than a Planck length in size. And it's at that point that we actually apply standard, completely trivial standard physics and quantum theory, basically, to start calculating the predictions of inflation. This is like around 65 or 70 e-folds before the end of inflation. That's a stage where we start. We apply standard physics and compute as if nothing is happening, nothing unexpected is happening. But that is a regime where the universe is below a Planck length in size, and all known physics as we know it essentially breaks down. We need to apply quantum gravity. We don't know how that works, how quantum mechanics works. So this is one criticism of inflation. I have heard basically that it relies on applying standard laws of physics in a domain where we know that they break down. Now, I don't know if this kind of discussion figures out in this kind of philosophical reasonings or not. I have not come across it, but I wondered if you have seen it anywhere, basically.
I'm not aware of a genuinely philosophical treatment of this point. I mean, if I try to use both of your arguments in the context I try to develop here, I would think that they would amount to fairly significant arguments against the reliability of an alternatives argument in this context. I think that would be, one could say that in both cases, which doesn't mean that they fully devaluate an alternatives argument, but if to the extent they break the continuity with the ensembles of the meta-inductive argument, that generates serious problems for an alternatives argument. Because of course, as long as so there are two aspects to the way alternatives arguments and meta-inductive arguments play together. First, the alternatives argument of its own, of course, is always threatened by the possibility that scientists are just not clever enough to cover the alternatives. And this is countered, or this is controlled. The idea is, the mechanism would be that this is controlled by the meta-inductive argument. So you look at comparable cases and check whether they were capable enough to cover the space of possibilities there. And if that tends to be the case, then you say, okay, if it has worked so often, maybe we can trust it here as well. Now, the points you're making from this meta-empirical assessment perspective are both points of discontinuity, so to say. So the first one is straightforward discontinuity, saying that in those cases where it worked based on a fundamental principle that is absent here. So maybe it works if we have a fundamental principle, but it doesn't if we don't. So that would be the argument there from a MEA perspective. In the second case, it would be that the argument would be that normally that your claim, I mean, without fully understanding your argument, but the upshot of the argument would be that normally we don't do that. Normally we are less daring in applying those principles to contexts where we have so little control over whether they work, or maybe we may even expect that they don't. So once again, that's a different situation, and in such a situation may also suggest that there is more uncertainty, and there is more potential for entirely new ideas than in other better understood contexts. And once again, that would weaken a meta-inductive argument, and therefore also weaken the significance of an alternatives argument. So that's what I would say about this. So I think that at that level, at the meta-empirical assessment level, those would be arguments that would play out, that would be very significant arguments in weakening an alternatives case.
Yeah, I think I find that very reasonable, basically. Yes.
I think we don't have more questions, so let me ask a question. And it's a bit of a cynical / hopeless question, to be honest. And question is, if you really think that this kind of like meta-empirical approach could, to some extent, lead us to consensus over time about a given framework or theory. So I guess these also touched a bit on the sociology of academia or of the research programs, right? Because there is the lack of, I guess, direct empirical evidence in this case might be completely overwhelmed by the personal commitments that people might have onto those programs, right?
Yes. Well, at this point, the fair assessment would be that it doesn't, right?
Yeah.
So currently, the situation is always the situation where there is no conclusive empirical evidence is always characterized. It may be characterized by a majority or even a considerable majority having one position, but others who are quite strongly opposed to that position, and also would claim that the majority exaggerates the merits of those positions and does not have the epistemic basis to endorse that theory. And I would say that, I mean, one would be a speculative projection that if we assume, so it seems to me that fundamental physics today is characterized by these types of situations to a much higher degree than earlier physics. So it's a new situation physics finds itself in. So I would think that in the long run, physics will need to, and probably will, develop more fine-tuned or better working processes of making those assessments, and therefore also for finding agreement to the extent that's reasonable, let's say. And at this point, it seems to me that there are two levels of disagreement that are quite difficult to distinguish from each other. There is one meta-level disagreement and one ground-level disagreement. So what Fawad was saying, that would be a ground-level disagreement, right? It could be perfectly fit into a meta-level assessment debate, and in that debate, it could show, if correct, or if it stands the test of the debate, let's say, it could show that actually the meta-level arguments in favor of inflation are considerably weaker than the defenders of inflation take it to be. So that would be a ground-level debate that has to play out. And there may be disagreement, it may not be clear at this point, but when one could eventually come to an agreement. So along the lines of scientific exchange, I feel. Then there is the other aspect where sometimes there is a fundamental rejection of meta-level strategies as a matter of principle by some participants to the debate. And as long as that is going on, I think an agreement is basically impossible, because it's not a scientific disagreement. It's a kind of it's a philosophical disagreement, let's say. So they say we don't want to take a theory that seriously. We want to speak about speculation as long as there is not conclusive empirical confirmation. And if that means that there is no conclusive empirical confirmation for, let's say, 200 years to come, so be it. So that would be their claim. That is, of course, that can also be debated, but it has to be debated at a meta level. And the question would be whether at this meta level a consensus will emerge. But I would think that the consensus at the meta level, if one compares those two processes, at the ground level, there is a well-rehearsed and well-entrenched process of scientific reasoning that can make this play out. While these mid-level issues, they are not. There is no well-known process how this works. So it's difficult to predict. Maybe the consensus will emerge, or maybe not. I don't know.
Because one thing that's interesting, I guess, tagging along with the latter option or scenario, I heard from conversation between Brian Greene and Sean Carey about string theory. And what Brian Greene was saying was that his hope is that actually, or expectation is that string theory is going to become a subject of the mathematics department. And so instead of like reaching any sort of consensus, it's going to actually become just part of math as opposed to part of physics. And then you're allowed, I guess, to work as much as you want on the theory without regards to any sort of like empirical confirmation or even Meta-Empirical confirmation.
Yeah, I would quite strongly reject that perspective, I must say.
Yeah. Okay, we have no more questions, and it's been quite a while that we're doing the Q&A. So I guess we can end here. So thanks again for the very nice talk. And thank you all for all the questions and comments. And yeah, I see you.